In this video, I'm going to solve this organic chemistry predictive product problem where this is going to be halogenation of an alkene in a product solvent like alcohol. So this alkene here is going to be very nucleophilic because it has a pi bond with electrons that can attack this bromine here and kick out the other bromine. And as this bromine is gaining electrons and this alkene is losing electrons, this bromine here is going to attack the other carbon of the alkene, forming this bromonium ion here. Once we have this bromonium ion, we now have a competition between two nucleophiles, the Br minus that got kicked out, and this ethanol from the product solvent we have here. And the one that will overpower the other one is going to be ethanol because there's an excess amount of ethanol compared to bromine minus, and also bromine is an electronegative atom which will keep its electrons and not want to attack, not want to give it up and attack. Whereas oxygen here of the ethanol is less electronegative than bromine, making it more willing to attack and making it a better nucleophile. And think of this as an acidic conditions in epoxides, where we're going to attack the more substituted carbon of the bromonium ion, which is this carbon right here, kicking out this bond and inverting this bond like an SN2-like mechanism, where this is the new bond between the carbon and oxygen, and this bromine here is this bromine of the bromonium ion, where this wedge bond is that wedge bond that was untouched. Nothing touched that bond, so we don't invert that bond. But this dash methyl gets inverted to a wedge methyl because we inverted this wedge bond to a dash bond, where the final step is to bring in a second equivalent of alcohol as a base to deprotonate this oxygen and make it neutral and stable, giving this the final answer. Plus, it's enantiomer because this could have been switched around if this bromonium ion was a dash and this methyl was a wedge.